Good morning. It's April 23rd, and this is your daily brief in science. Here's everything you need to know. A recent study published in Cell Reports highlights the connection between sleep patterns and cognitive performance in adolescence. Researchers found that teenagers who sleep longer and go to bed earlier exhibit enhanced brain function. The study involved over 4,000 participants, including 3,222 children aged 11 to 12, who tracked their sleep using Fitbits as part of the Adolescent Brain Cognitive Development, or ABCD study. Participants were categorized into 3 groups based on their average sleep durations, which ranged from 7 hours 10 minutes to 7 hours 25 minutes. Notably, none of the groups achieved the recommended 8 to 10 hours of sleep, indicating a significant sleep deficit during this crucial developmental stage. Researchers are exploring various factors influencing adolescents' sleep patterns, including video game usage and natural body clock variations, to understand the trend of late bedtimes. Co-author Barbara Sahakian from the University of Cambridge pointed out that even minor differences in sleep duration can have substantial effects, suggesting that cumulative benefits may accrue over time. The study revealed that small differences in sleep duration, averaging just over 15 minutes, were linked to significant variations in brain structure and cognitive performance. Dr. Ching Ma from Fudan University noted that, while the study does not definitively establish causation, existing literature supports the positive impact of adequate sleep on memory and learning. To improve sleep quality, Sahakian recommends that teenagers engage in regular physical activity and limit screen time before bed. The findings of this research underscore the importance of sleep in adolescent health and its critical role in cognitive development, with implications for both educational and health strategies. A newly discovered exoplanet is raising eyebrows in the scientific community due to its alarming rate of mass loss. Researchers from the Massachusetts Institute of Technology have identified BD plus 054868 AB, located approximately 140 light-years away in the Pegasus constellation. This planet, roughly the size of Mercury, orbits its star every 30.5 hours and experiences extreme surface temperatures nearing 3,000 degrees Fahrenheit. The intense heat on BD plus 054868 AB leads to surface temperatures around 1,600 degrees Celsius, causing the vaporization of rocky material into space. The planet is shedding about 1 Mount Everest's worth of rock material with each orbit, suggesting it could face complete destruction in just 1 to 2 million years. Its weak gravity further complicates its situation, as it struggles to retain mass, accelerating the loss of material. Interestingly, BD plus 054868 AB has developed a comet-like tail extending up to 9 million kilometers. This tail is composed of mineral grains evaporated from its surface, setting it apart from other exoplanets that typically exhibit tails made of gases or ice. Notably, it is only the 4th known exoplanet to possess such a feature and has the most catastrophic evaporation rate among them. Mark Hahn, the lead researcher, has indicated that BD plus 054868 AB's situation is among the most critical, as it is expected to vanish faster than other known disintegrating planets. Unlike other tailed exoplanets, which are usually gas giants, this rocky planet's rapid disintegration highlights its unique and short lifespan compared to others that may endure for hundreds of millions of years. The existence of BD plus 054868 AB was confirmed using data from NASA's Transiting Exoplanet Survey satellite, which detects exoplanets by observing light dips during their transits. To further investigate the planet's composition and its tail, researchers plan to utilize the James Webb Space Telescope, aiming to gain insights into the diversity and habitability of rocky planets. The team is also analyzing test data for similar unusual signals to identify more disintegrating planets, enhancing our understanding of terrestrial planets in the galaxy. Researchers at the University of Oregon have made a significant breakthrough in iron production by developing a method that eliminates the reliance on fossil fuels. This innovative approach utilizes electrochemical processes, which could play a crucial role in reducing carbon emissions from the steelmaking industry, a sector known for its substantial greenhouse gas contributions. Traditionally, Steel production has depended on carbon-heavy blast furnaces, but the new method employs saltwater and iron oxide to generate pure iron through electrochemical reactions. This cleaner technique not only addresses environmental concerns, but also uses inexpensive reactants, positioning it as an economically viable alternative to conventional methods. Recent laboratory tests revealed that porous iron oxide nanoparticles can produce iron at a faster rate than denser particles, which is essential for scaling the process economically. The research emphasizes the importance of larger surface area electrodes to enhance reaction rates and potentially reduce production costs, making this new method competitive with existing steelmaking practices. Led by chemist Paul Kempler, the team advocates for utilizing naturally sourced, variable iron-rich materials instead of relying solely on purified chemical supplies. To transition from laboratory success to real-world applications, the researchers are collaborating with civil engineers and an electrode manufacturing company to tackle scalability issues. They have established guiding design rules to identify low-cost iron oxides that could improve the efficiency of the electrochemical reactors. With nearly 2 billion metric tons of steel projected to be produced globally in 2024 using fossil fuel-intensive methods, the potential for decarbonizing iron production could lead to significant reductions in greenhouse gas emissions, comparable to converting all gas vehicles to electric. This highlights the importance of this research in the broader fight against climate change. A recent study has revealed a compelling link between physical activity and cancer risk reduction. Conducted by the National Institutes of Health and the University of Oxford, the research indicates that engaging in daily light to moderate physical activity, such as walking 9,000 steps, can lower the risk of over 10 types of cancer by 26%. The study involved more than 85,000 adults in the UK who wore wrist accelerometers for 1 week to accurately measure their activity levels and intensity. The findings, published in the British Journal of Sports Medicine, provided insights into participants' total daily activity, intensity, and step count. Over an average follow-up period of 5.8 years, 2,633 participants were diagnosed with one of 13 cancer types, including breast and colorectal cancer. Those with the highest levels of physical activity experienced significantly lower cancer risks compared to their less active counterparts. The research showed that higher daily step counts were associated with reduced cancer risk, with an 11% reduction for those walking 7,000 steps per day and a 16% reduction for those reaching 9,000 steps. Notably, the benefits plateaued beyond this point. Additionally, the study found that replacing sedentary time with light or moderate to vigorous activity was linked to lower cancer risks, regardless of other demographic and lifestyle factors. Researchers at the University of Oxford have unveiled a groundbreaking ultrasound-activated nanoparticle drug delivery system aimed at tackling bacterial biofilms, which are a major contributor to antibiotic resistance. This innovative system employs engineered nanoparticles that release antibiotics when activated by ultrasound, enabling non-invasive disruption of biofilms and targeted treatment of infections. The effectiveness of this approach is particularly notable against persister cells, with the system reducing the required antibiotic concentration by 25-fold in comparison to traditional methods. In instances of biofilm infections, the nanoparticle system has been shown to decrease antibiotic requirements by more than 40-fold, successfully eliminating all bacteria at clinically viable doses. Professor Eleanor Stride emphasized the pressing need for such advanced treatments to extend the effectiveness of antibiotics against chronic infections. Biofilms are linked to various difficult-to-treat infections, such as chronic wounds, urinary tract infections, and lung infections associated with cystic fibrosis. These protective matrices formed by bacteria pose a significant challenge, as they can shield bacteria from immune responses and drugs, potentially increasing resistance by up to 1,000-fold. The nanoparticles were tested against 10 clinical strains, including E. coli and MRSA, showing a reduction in the antibiotic concentration needed to inhibit bacterial growth by over 10-fold in the absence of biofilms. Currently, the research team is focused on refining the nanoparticle manufacturing process in preparation for clinical testing, with their findings detailed in a recent publication in NPJ Antimicrobials and Resistance. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.